Ayan. Sige, so hello. Welcome ulit sa ating lesson today. Okay, so we're going to have the same setup as yesterday. We're going to try to finish as early as possible kasi mas maganda if you can try to work it out on yourselves. Kasi mahirap itong topic na to, Chemical Kinetics. Sa klase namin ng grade 10, halos lahat kami dito bagsak. So, ganun siya kahirap, okay? Kasi nakakalito siya. So, let's start. Yun, chemical kinetics. This one is quite different from the chem you usually do na kasi it's going to focus more on the reactions na talaga. Marapit na siya sa stoic, pero iba pa rin siya, okay? Sige, so, chemical kinetics is the study of how fast reactants change into products. Or in another term, ang tawag doon ay reaction rates. In short, study siya ng reaction rates. So, we look at reaction rates either in terms of products or reactants. Equilibrium kapag hindi na gumagalaw at all yung products and reactants. Okay? Then, syempre, pag mas mabilis yung reaction rate, so if you look at in terms of the reactant, mas mabilis mag-change into products yung reactants natin. At pag mas mababa yung reaction rate natin, syempre baliktad, mas magbagal mag-change into products yung ating mga reactant. Okay? So now, let's go into it na agad. So reaction rates. So ang reaction rate, sabi ko nga, change in reactant or product concentration as a function of time. Okay, example. Ayan, just to illustrate yung sinasabi ko kanina, faster reaction, mas mabilis maubos yung mga reactant natin, di ba? Mas konti na kaysa dito sa pangalawa kasi mas mabagal siyang mag-react. So, ibig sabihin, mas mabagal mag-change into reactants, mas mabagal mag-change into products yung ating mga reactants. Then, okay, what affects reaction rates? So, syempre, before we start, ito yung pinaka-premise natin. In order for a chemical reaction to take place, molecules must collide to react. If you imagine it, kailangan magbangga-bangga sila and mag-mix up para mag-react and change the product. So, example, when we increase yung concentration, nakapag anong ba kayo last year? Yung mga concentration last year, ganun sa grade 9 or hindi? Yung mga moles per liter, ganun. Na-cover nyo ba yon? Solutions, bale, ng grade 9 kayo? Yes or no?
Yung molarity at modality.
Ayan. Nagawa nyo ba yon?
Hindi pa.
Ay, hindi pa? Talaga?
Hindi pa.
Nako. Okay, so sige, bago tayo mag-start, sige. Hindi ko pala alam na hindi nyo pa nagagawa yun. Sige, wait lang ha. Teka. Just a short crash course. Kasi ito lang naman yung ibig sabihin doon. Don't worry, we wouldn't be doing pa naman yung stoichiometry talaga with the Sige, molarity. Kasi most of the time, solutions yung mga what we're dealing with right now. So, molarity is simply moles solute over liter ng, teka, check ko lang ha. Hindi pa pala nagagawa to. Molarity definition. Okay, number of moles of solute over liter ng buong solution mo. So, example, kapag sinabi kong, 32 grams of, ito, 24 grams of carbon in 2 liters solution. Ang molarity ng solution natin ay syempre convert natin to moles. ang molar mass ng carbon ay 12 grams per mole, di ba? So, 2 moles of carbon over 2 liters solution. So, kapag simplify natin yan, 1 molar. Ang M, yun ang unit of, yun ang unit ng ating concentration. So, you'll see this quantity a lot sa lesson na to. Okay, gets naman yung basic premise ng concentration. Yun lang naman siya. Okay naman?
Yes,
Gets naman.
Okay, sige. Don't worry, ito na naman. This is the basic ones we'll use for now. At least, ito pala, natanong ko sa inyo. Okay. Yung next lesson kasi natin will require more. Okay, let's go back to our presentation. Ayan. So, balik tayo. Kaya, concentration, kasi solutions nga. Then, syempre, the more moles na nandun sa solution natin, mas magko-collide. Kasi nga, mas marami yung molecules, di ba? So, mas magko-collide yung reaction natin. And therefore, tataas yung rate ng pag-change into into products. So, yan, no? Example, ito, konti lang yung concentration natin of each. So yung rate yung rate of reaction nila mabagal syempre. Pero kapag in-increase mo, ayan, dadami, so mas magbabangga-bangga sila and therefore mas magre-react yung ating mga chemicals. So yan. Next is physical state. Surface area or particle size. Molecules must mix to collide. Ibig sabihin nito, kapag higher surface area, medyo counterintuitive siya. Kasi in chem, when we mean higher surface area, it means na mas fine yung mga particles na dinidissolve natin. Kasi, example, yung iced tea, di ba? Kapag mas fine and mas powdery siya kaysa yung mga buo-buo na, mas mabilis siyang mag-dissolve, di ba? So, ayun. We'll look at this in the next picture. Ayan. So, itong Mg natin, tinatry natin i-dissolve into this in this acid and water solution. So, kapag pinaghiwa-hiwalay natin, or in essence, pinalaki natin yung surface area, mas malaki yung chance na mag-bump yung mga particles ng acid and water sa isa't isa sa magnesium. So, ayan, mas tataas ang reaction rate. So, temperature. Siyempre, molecules must collide with enough energy. So, di ba, pag temperature, mas mataas yung temperature, mas mataas yung kinetic energy natin. Or in other terms, mas nagko-collide yung mga particles natin and as a result, mas malaki yung collision energy nila. Therefore, that increases yung reaction rate. Ayan, no? Example, dito sa figure natin, ayan, they're not that active. Di sila masyado nagbabangga-bangga sa isa't isa. Pero, pag increase natin yung temperature, ayan, more energy sila, mas mabilis sila magbangga sa isa't isa. Therefore, mas frequent and mas successful ang ating mga collision. Gets naman? Okay, Gets naman? Okay. Sige. Ito naman. So, this is our main part of the lesson. Ito. Ay, nag-gets naman yung kanina? Okay naman?
Apa.
Okay, sige. So, ito naman, for expressing reaction rates, it's just simply like this. For a general reaction, A turns into B, the rate of the reaction in respect to the reactant is negative delta A over delta T. Teka, just some new terms. This is another way of expressing concentration ng A. Instead of writing concentration of A, ang ginagawa natin, we write it in brackets, okay? You'll see this a lot ngayon. Okay, itong rate is expressed in molar per liter second, or kapag tinignan niyo mabuti, mole per liter is capital M per S. Okay, remember that. Next, bakit parating negative? Kasi kung isipin natin, ang mangyayari, mas maliit, 'di ba, delta. Yung final na amount of reactants natin, kasi nagiging product na siya, for sure, mas maliit siya kaysa sa una. Kaya nilalagyan natin ng negative. Okay? So yan, for example, concentration of A changes from 1.2 mole per liter to 0.75 mole per liter over a 125 second period. So final minus initial over final time minus initial time equals this one. Okay? Yun lang siya. Simple lang siya. Pero, naman, sabi ko nga, in rate naman can also be expressed in terms of product. Rate respect to product is delta concentration of B over delta T. Ito parating positive kasi, di ba, dumadami yung product kapag nagre-react. So, therefore, mas mataas parati yung ending concentration kaysa sa unang concentration niya. Same, expressed in mole per liter second or mole per second. Okay? Sige. Ito. Paano naman pag ganyan na? The rate of this reaction can be expressed in this. Ito, kaya ako ito highlight kasi I'm expressing the rate in the perspective ng C2H4 gas. The rate of this reaction in respect to C2H4 gas is this, or which is equal to this also, this also, this also. Okay? Ito yung mga reactant, ito yung mga product. Okay? Pare-pareho lang yan. So, okay, let's just look at this graph. Ayan. Pansin nyo, yung concentration, parang medyo fractional, 'di ba? Kasi nga if we look at here as a function of time, your rate nagbabago parati siya depende sa concentrations, 'di ba? Okay? We have different types of reaction rates. So unang-una, average rate. Ito yung slope of the line joining 2 points on the curve. So example, average rate over the first 60 seconds, we take this and that. So, ayan, final minus initial over time, change in time. We'll get 3.5 times 10 to the negative 7 molar per second. Gets naman? Okay naman?
Yes, sir.
Okay, sige. Next, instantaneous rate naman. Tulad sa physics, anything na instantaneous, slope of the line tangent to the curve at that particular point. So, example, the instantaneous rate at t equals 35 seconds, this one, ayan yan, is around 2.5 times 10 to the negative 7. Okay? Kasi kinukuha natin yung slope. Yung slope niyan is the rate. The lastly, initial rate, syempre, rate at t equals 0. So, ayan. 10 times 10 to the negative 7. Okay. Next, expressing reaction rates. So, yan. Sinabi ko na ito kanina. So, ano ba ibig sabihin nito? For every 1 mole of C2H4 and 1 mole of O3 that reacts, magkakaroon tayo ng a yield of 1 mole ng C2H4O and O2. So, kung titignan natin graphically, halos pareho lang yung pagka-rise and pagbaba nila. Pero paano pag ganito? Mas mabilis dumami yung twice as much bumilis yung concentration ng products kaysa sa reactants, di ba? So, pag tinignan natin yung graph ng HI, mas mataas talaga siya, mas steep siya, di ba? Kasi nga mas mabilis siya kaysa sa reactants niya. So, if we're going to express the rate in the perspective of H2, yung reactant natin, ito yung kalalabasan. So, take note at 2, 1/2. So, next, if you look at naman yung perspective ng HI, ayun nga, twice as much yung pagbilis niya kaysa sa I2 and H2. So, pwede rin natin express as that. Okay? So in a general sense, dependent sa coefficients ng balance equation mo yung rate ng mga pagdami and pagwala ng mga reactants and products mo respectively. Pag in-express natin in general form, ito yung formula. Yung reciprocal ng mga coefficient times concentration A, B, C, D over delta T. Okay, gets naman? Gets? Gets naman, guys?
Yes.
Gets naman po.
Okay, sige. Now, let's try this naman. Sige nga, send nyo sa akin sa messenger when you're done. I'll give you mga 5 minutes, okay? Ayan. Sige, go. Go lang. Okay. Sige, let's examine yung mga sagot natin. Tara lang ha. Let's discuss. Okay. Sige, discuss muna tayo. Nakikita ba yung sulat ko sa whiteboard? Nakikita ba, guys?
Kita
Dito
naman.
naman po.
Okay. Sige. Game, ha? Di ba, ano? Rate. Pag reactant, parating negative na agad. So, negative 1/2 delta H2 over delta T equals negative O2 delta O2 over delta T equals positive kasi product. 1/2 H2O over delta T. So, yung mga kanina ay isosum na teko isosum na medyo mali. Ngayon, ingat lang sa signs. Ayan kanino to? Kay Meliza, kay Megan. Ingat lang sa signs, okay? Basta pag negative, pag reactant yung nasa equation, negative siya. Pag product, positive yung rate niya. Okay? Sige, for letter B, let's see yun if when O2 is decreasing at 0.23 molars per second, at what rate is H2O increasing? So, ito raw. When O2 is decreasing. So, ito raw, negative 0.23 molars per second equals 1/2 rate ng H2O. Ito. Yan. Delta H2O over delta T. So, if we solve that, delta H2O over delta T equals 0.46 molar per second. Okay? I think everyone got that naman. Manuel, ingat lang sa wording. Ayun. Sige, next. So, ngayon ito na, one of the most important parts ng lesson natin, rate law. Okay, ano yung rate law? Teka lang You switch back. Ang rate law ay function of reactant lang. Reactant take note, reactant concentrations and temperature. So, for a general equation where A, B, C, D are the balance of the balance equation, the rate law for this, or basically yung reaction speed natin, rate natin ay K times A raised to M, concentration of A raised to M, concentration of B raised to N. Nawala ako sa camera. Teka lang Fix my camera. Tanang guys Sorry. Tanang guys Wait lang. Sira yung ko. Ayan. Now, let's go back. Sige. Ito. The balancing coefficients, di ba kanina sa rate, expressing ng reaction rates, hindi kailangan, ay sa balance coefficient siya nag-matter. Ito naman hindi. Kaiba siya. yung tawag sa M&N ay reaction orders. We'll get into that later. Lahat ng mga components na to, itong K, M, and N, they don't depend on the balance equation. They are experimentally determined. We'll see later kung bakit ganon. So, ano sabihin reaction order? Ang reaction, meron siyang order with respect to sa bawat reactant and an overall reaction order, which is the sum of the individual orders. So, example, pag first order reaction, pag nag-W rate, teka lang guys ha. Ano yun? Ano yun? Oy, pa! Okay, I'm sorry. So, let's go back. Ayan, pag first order reaction, if the rate doubles when A doubles, ayan, Ka raised to 1. Sabihin, 1 yung order niya in respect to A. Pag second order reaction, pag nag-quadruple yung rate, pag nag-double yung concentration ng A, edi second order yun. Sabihin, 2 yung exponent. And pag zero order, the rate does not change when A doubles. So, kahit ganong karami yung dinamihan natin sa concentration ng A, wala siyang pake. Still the same. Zero order yon. Sabihin, zero yung exponent. So, for a general reaction where A, B, C, D are the coefficients of the balance equation, the rate law is K times A raised to M, B raised to N. And yung overall reaction order, M plus N. Okay? So, ano pa yung implication nun? Ito, just a graphical interpretation. Ayan, no, pag zero order, line yung concentration of A versus time kasi hindi nag-change. So, yung slope niya is just a horizontal line. Pag first order reaction naman, ayan, yung pag-decrease niya is a constant rate. Kaya yung slope niyan, straight line. Pag kinuha natin yung derivative niyan. And lastly, second order reaction. Ayun, mas steep yung pag-decrease niya kasi nga, ayan, nag-iiba-iba yung pag-change ng rate natin. So, ito, just some examples of other reactions. Itong reaction na to, first order siya with respect to NO and O3 kasi 1 lang yung exponent ito. Second order overall kasi 1 plus 1 equals 2. Second order siya with respect to NO. First order siya with respect to H2 and therefore yung order niya, third order. So, ayan, kita nyo to. They do not depend on the coefficient ng balance exponents, balance coefficients. Ito kasi si H2 kahit ito yung coefficient niya, first order lang siya. Okay? Remember that, ha? So, meron din tayong fractional na reaction order. Example, ito. Itong sa Cl2, hindi siya pareho. 1/2 yung kanyang reaction order. So, pwede yan. Overall reaction is 3/2. And pwede rin negative. Yan, tulad dito. So, overall reaction order is 1. Okay? So, let's try this out. Ayan. Sige. Go. Kahit type na lang yung sagot. Mga 2 minutes lang to. Sige, let's wait for 2 minutes. Okay, let's see. Sige. Tama naman. Good job. Good job for everyone na sumagot. Tama lahat na. Okay, let's wait for a little bit more. Okay, good job. You're all correct. Sige, let's discuss briefly. Overall reaction order, 2 plus 1, 3. Reaction order according to each reactant. Second to NO, and first with respect to O2. What happens to the rate if NO is tripled? Ay, wait lang. Guys, tripled yung, tripled yung NO. Bakit 8 times lang? Tripled yung NO Baka na mali kayo ng basa. So, pag tripled yung NO, 9 times 2. So, it's 18 dapat. Okay? Yun lang Okay? Gets naman? Really? Okay, I'm sorry. Talaga? Parang... okay. Sorry. Hindi ko napansin. Okay, sige. Okay, sige, let's go. Sige, initial rates method. Ito na yung one of the main parts. So, sige. Determine the overall reaction and the rate order for the reaction. I rate constant for this reaction. It follows the rate law na ganito. From the following experimental data. Ito na sasabi experimentally na determine lahat yan. So, yan. Sige, I'm going to demo. Sige. I'm gonna put the data in one side. Sige, I'm gonna use the whiteboard for now. Kasi medyo, para mas, demonstrative tayo. Sige. Sige, so, ito. Yung bawat reaction na yan, yung bawat experiment na yan, meron yan sari-sariling rate law. Diba? I mean, you can express the rate law of each. So, example lang. Yung R1 natin, pwede siyang K times O2 not O21 raised to M and NO 1 raised to N. Yung R2, sabihin natin ganyan, O2 raised to M 2, NO raised to N2. So, to see kung ano yung mga ano natin, to see kung ano yung mga M at N natin, we divide both. Right? Kasi, express natin as 1. Yan. Resolve this. Bale. Pag diresolve natin yan, we will be able to find M and N by the use of a little bit of algebra lang. Sige, let's try So, ang technique is to look at kung ano yung makakancel mo. In short, paano ba magka-cancel yung isang ano natin kapag pareho yung concentration nila. Tama? Nakuha ba yun? So, nakuha ba yun? Okay. Nakuha ba yun? So, for example, anong dalawang experiment muna yung pag-prepare ko para makuha ko yung exponent for O2? Sample ito. Bakit? Kasi if we look at closely, magka-cancel to. Kasi pareho sila ng concentration. Okay? So, solve natin. Yung mas malaking initial rate over yung mas maliit. So, R2 over R1 equals K. K. So, ano natin? Cancel natin yung K. Tapos yung NO, pareho lang siya ng concentration. So, ika-cancel natin. So, what's left? Ito. Ano yung nandito? Ito, 2.20 times 10 to the negative 2 over 1.10 times 10 to the negative 2. So, let's divide. Substitute. R2 over R1. Pag divide natin yan, nasa around 1.99 yan. Kasi sobrang lapit sa 3.21 times 2 eh. So, it's gonna, So, pag nag-divide kayo, i-round up nyo yun. So, 6.40 over 3.21 times 10 to the negative 3 is around 1.99. So, we can round up to 2. 2 equals, ito. Diba? 2 raised to M. Nag-gets kung bakit ganon? Okay naman? Nakuha ba yun? You get it naman?
Yes, naman, sir.
Okay. Yan. So, ano yung value ng M para maging equal to? 1, di ba? Yan. So, meron na tayong exponent for O2, which is 1. Ngayon, kuha naman tayo ng next set of values. So, we can look at experiment 1 and 3. Right? Kasi, we can look at experiment 1 and 3 kasi, pareho sila ng O2 concentration, pero hindi yung NO concentration. So, let's try again. So, R3 over R1 equals to 12.8 times 10 to the negative 3 over 3.21 times 10 to the negative 3 raised to M. Ay, sorry. Mali pala ako. Ay, sorry. Sira pala camera ko, no? Teka. Let me fix for a while. Sira to, Nangyari. Okay, sige. Sorry for the technical difficulty. Ayan, sorry. Ayan, sabi ko kanina, let's choose rate, experiment 3 and experiment 1. So, substituting 12.8 times 10 to the negative 3 over 3.21 times 10 to the negative 3, mga 1.98 yan. So, sorry, mga, let's see, mali pala ako, 12.8 divided by 3.21, 3.98 pala, 3.98. So, mga around 4 yan. So, pag divide natin, cancel na yung O2 kasi pareho sila ng concentration. So, 4 equals, itong NO divided by NO, 2 yan, di ba? 2 raised to N. So, mga N equals 2. Nakuha naman kung bakit ganun, na. Okay? So, our rate law can be expressed like this. Our rate law natin, therefore, ay rate equals K times O2 in O squared. Ano yung overall reaction order?
3 pa.
3. Okay, tama. Tapos, yung rate constant. Paano mo ko yung rate constant? Ang gawin na natin, we substitute any experiment. Makukuha natin yung rate constant. So, sabihin natin experiment 1. So, bale, K equals rate over K times O2 and O squared. So, substitute lang tayo. Sabihin natin sige, experiment 1, 3.21 times 10 to the negative 3 over O2 times NO squared. 3.21 times 10 to the negative 3. 3.21 times 10 to the negative 3 over O2, which is 1.10 times 10 to the negative 2 times 1.3 times 10 to the negative 2 squared. We'll get mga, let's see, tama ako. Yan, tama. 1.73 times 10 cube liter squared per mole squared is. Okay, just mali ako dito. Dapat 3 ito. 3 yan na. Ang units natin, nagbabago. Hindi siya parating mole, hindi siya parating same unit, It changes according to the order of the reaction, overall order. So, itong liter squared per mole squared second, nakalito siyang sulat, pwede siyang, pwede siyang 1.73 times 10 cube per mole squared second. Okay? Nagets naman yung demonstration natin. Nagets naman, guys. Ano, guys? Do you get it?
Ayun lang siya.
Ayos lang. Sige. We'll do more of this mamaya sa sa exercises ko. So, kasi medyo yung next part yung mas mahirap siya. Sige, let's start. Yan. Pero ano lang yan, to be able to determine kung ano yung unit ng K for a specific order ng reaction, it's just important to do a dimensional analysis na lang. Okay? Sige. So, integrated rate law. Ito yung rate as a function of time. Dito na tayo gagamit ng regression. You'll see later. I just go straight into it. Para ma-derive yung mga formula nito, kailangan may calculus. Pero never mind. We'll not cover that right now. So, example yan. For first order reactions, di ba, yan yung form niya. Pag integrate natin, ito lalabas. Kaya lang, ito, masusulat natin as a graph plotted ln A versus ln versus time. In seconds yan, in seconds. So, changing this into the form y equals mx plus b. Yan yung lalabas. Okay, gets naman, ha? Gets naman? Yan, I remember this. Okay, next. So, ay, nakikita naman yung PowerPoint ko, no? Sige, ulitin ko lang. So, baka di na nakita. So, first order reaction, ang rate niya, ito. by integration sa calculus, ito makuha natin. Then, ayan, kasi yung mga ganito, we can plot it according to ln versus time. So, just transform the equation into something like y equals mx plus b. So, magiging ganito siya. Nakuha naman yun, guys. Okay naman?
Ayan na, sir.
Sige, we'll look at more of this later. Second order, ito makuha natin. Pag ginawa natin siya linear, ayan, positive slope up siya. Ito makukuha natin. Y equals mx plus b. And sa zero order, ayan, by plotting, ito makukuha natin. Y equals mx plus b. Sige. Paano ginagamit to? So, given a set of data, plot the given data using your calculator. Sa calculator, kasi iba yung calcu ko eh. Nakapag-regression ba kayo last year? Sa calculator or hindi? Ano guys? Nakapag-regression ba kayo sa calculator or hindi? Sa stat?
Slight lang, sir.
Slight lang. O sige. Sige mamaya, we'll do this together. Okay. Ayan. So, bali, tatlong table yung gagawin niya parate. You'll see later, Yung isa, ln reactant versus time. Tapos, yung susunod, 1 over reactant versus time. Yung isa, zero order, ay yung concentration versus time. May Excel ako for this. So, ngayon, check yung R squared. Ito, na-discuss nyo kung ano yung R squared.
Kaya ba yung error or something?
Okay. Ang R squared, yun ang correlation coefficient. So,
Ay, fine.
R squared. Actually, R lang. Pero mas sa data, pag sa mga research, ganun, parating tinitignan R squared. Mas reliable kasi yun. So, the nearer is it to 1, the better it is. Okay, so i-compare niyo yung R squared ng tatlo, tas get the biggest one. That's the order the reaction follows. Let's get the equation of the line. Then, conclude the overall order of the reaction. So, yan, given this, Okay, so, ito, example na. Following data for the dimerization of C4H6 are shown below. Ayan. Find the reaction order and give the integrated rate law equation, or basically, yung equation of the line. So, thus we need to find the rate constant. Then, we also need to find C4H6 at T equals 8,000. Okay, sige. Sige nga, ito muna. Exercise muna. Teka, I'll share my screen, you are presenting your entire screen. Tapos tingnan natin yung Excel ko. Nakikita yung data and the screen. Nakikita naman, no? Okay? So, ito yung sinasabi ko kanina. Sige nga, as an exercise, can you guys give me yung equation for the line kapag pinlat mo yung itong dalawa. Nakikita ba? Kasi tatlong table yung gagawin natin, di ba? Unang-una, yung concentration versus time. Yung susunod, ln versus time. Yung susunod, 1 over concentration versus time. Parating tatlo gagawin nyo. It's more of trial and error. So, sige nga, as an exercise, can you show me yung equation ng line na makukuha nyo from plotting C4H6 versus time? Sige, let's go. Refresh lang paano gumamit ng regression sa calculator. Di ba meron dyan, statistics na section? parang pipindutin mo yata, setup, tas number 6, tama ba?
Opo.
Okay.
Tapos, gagamitin ba yung y equals a plus bx?
Yon, tama. Y equals a plus bx. Tapos, input nyo lahat doon ng data nyo for C4, H6 versus time. Sige, let's go do that first. Okay, yon, sige. Nasa inyo pa naman yung puti yung calcu, di ba? Tama naman.
Yes, sir. Andito pa.
Okay, sige, let's go. Hindi tayo magtatagal for a long time. Sige, let's spend mga 3 minutes for this. Sige, go. Tapos I'll discuss more later. Kasi ang kinaganda sa computer, sa Excel, sobrang dali lang gawin yan. Kaya ayun. Ano guys, na-i-input ba sa calculator yung iba, side row mo? Okay naman? Kamusta? Yung iba, na-input naman sa calcu yung mga values natin. Sige. Okay. Mo, that's good. Tama yan. Ay, wait lang. A plus bx. Okay, tama yan, tama yan. Good job. Okay, tama yan. Sige, we're on the right track. Good job. Ayan, so at least I know na you know how to. So, sige. Let's examine yung nakuha nyo. Pag pinlat natin sa line yan, look at the screen ha. Pag pinlat natin sa line yan, ito siya. Kung titignan nyo pa lang sa pagkaka-placing ng dots, ay, hindi siya line eh, di ba? Layo sa pagiging line. Tapos, di ba dyan, may r ka na. To get r squared, you simply square yung r. Okay, remember that ha? Yun siya. Actually, kapag nagbibigay ka ng equation of the line sa teacher, sa chem, you include the r squared parate. Just, the sum of life hacks, ganon. Yung iba, sina Megan and, Jeremy, nagawa ba? So, yan. So, obviously, if you look at the r squared natin, tingnan nyo itong Excel ko if you look at the r squared dito, baba, di ba? Ayun, no? 0.82 lang. Ang layo. So, obviously, hindi yan yung sagot. Okay. Ito yung next exercise ko sa inyo. Ito yung next exercise ko sa inyo, guys. Try nyo naman. Ang iba lumabas. Teka, ha? Okay. Can you show me kung ano yung in-input mo sa calcu? Baka nangyari sa'yo, nabaliktad mo yung, baka nabaliktad mo yung x and y. Kasi pag in-input mo siya sa stat, baka nabaliktad mo. Tama yung r eh. So, baka, ayun. Okay. Nga, I forgot to tell you guys, ang x natin ay yung time. Okay, remember that? The x is time. Yung y ay yung concentration natin. Always remember that, ha? Sige, hintay pa tayo. Kasi important na mag-gets nyo kung paano to. Balik tayo sa data. Yan. O sige, ito, para mabilis tayo, for the next one, exercise, plot nyo nga 1 over concentration versus time. Okay? Ito, 1 over concentration, 1 over nito versus time. Sige, try nyo nga. Let's see. Try nyo. Sige, let's go. 1 over nito versus, kumbaga, 1 over this, kumbaga, 1 over this versus this. Sige, let's go. Last gauge ko if you know how to do it na. Um, ayun, baka nabaliktad mo rin yung X and Y. Ang X natin ay yung time in seconds. Ang Y natin ay yung concentration. Can you take a picture nung calcu mo? Yung data mo? Desmos. Sige, teka ha. Um, y, X1. Wait. 0. Ay, mali. 3.37. Desmos yan, di ba? Wait lang ah. Tama ba? Desmos yan?
Opo.
Sige. Try ko rin ah. Yan, yung mga tapos na, i-graph nyo naman, i-regression nyo naman, 1 over this versus this. Okay? Sige, go. How to? Desmos. Zero, 1, 6, 3, 2, 4, 8, 6, 2, 0.01, 0.00504, 0.00337, 0.00253, 0.00208. Ano to? May residual. Drag. Baka, kasi, I'll be honest medyo weird yung interface ng Desmos for me. Kasi meron ito Meron itong residual. So, baka Jeremy, I think it's better if you try using another online calculator. Okay? Sige Kasi parang weird talaga siya for me. Kasi yung iba naman nakuha Saka sa Excel din nakuha. Let's see. Pero try mo na lang next time ulit in another calcu. Pero tama naman yung process mo, don't worry. Siguro weird lang talaga si Desmos. Sige. Check natin. 98.261 point talaga. Check mo ulit, baka may mali ka sa input. Si Megan tama siya. Yun yung dapat value. Yan, so examine yung value ng R na nakukuha nyo. Malapit siya sa Eliza, ganun din. Check again your input. Baka mali ng decimal place. Okay, I see kung saan mali si Eliza. Baka napagbaliktad mo ulit yung X and Y. Ingat ulit ha. Kasi tama yung R, pero yung, yung iba hindi. Okay. Ayun. At least, ayan na. Yun yung mga dapat ingat dyan sa lesson na to. Input ng values and yung pagbabaliktad ng mga yung pagkakabaliktad ng signs or ng X and Y. Ingat lang, ingat lang. Pero nevertheless, you guys are doing a great job naman. Sige. Try ko nga rin sa Desmos itong sige, in 2 minutes, let's discuss. Say, have a little bit more left. So yeah, talagang kasi sa chem, bawal naman magdala ng laptop eh. So ayan, para masanay na kayo, yun yung isa sa mga pinaka nakakainis na part sa chem 2. Ano na lang. Ayan, Manuel, that's good. Good job. Ayan, that's correct. Good job, Mo. Okay, sige, let's discuss. Let's discuss na. Kasi we're running out of time. So, sige. Ano napansin niyo sa R? Sobrang lapit sa 1, di ba? Pag kinuha niyo yung R squared niyan, it's actually exactly 1. Pag kinuha niyo yung R squared niyan. So, as an exercise, pero sige, we won't spend time for it na. Try nyo na lang next time, pag may time kayo, ln ng concentration versus time. Ito, itong pangalawang column. Pero next time na yun. We're running out of time. So, ito, let's look at the 3 plots dito sa Excel natin. Obviously, yung pinaka-fitting the line is this. Itong 1 over concentration versus time. So, yan, compare your R squared. So, the biggest one is this one, obviously. So, ito yung overall reaction order. Di ba 1 over something versus time? Ayun, kapag nag-plot tayo ng ganun, that's for second order equation, integrated rate law. So, therefore, our reaction is second order overall. Nagets ba yun, guys? Nagets yun? Gets ba, guys?
Get
Wait, sir.
naman.
Okay.
So, pag second order, mas straight yung line pag 1 over the values.
Okay, sige. Ito sige, let's go back to the concept. Sige, yan. Sige, pag nag-plot ka ng data, example, nag-plot tayo ng second order, ng 1 over versus time. Pag nakuha natin doon, very linear, super linear, greater R squared than the any of the two of these, ibig sabihin, second order yung reaction natin. Kapag naman nag-plot tayo ng ln, ng concentration versus time, then nakita natin na siya may pinakamalaking R squared versus the others, which means na super linear niya, ibig sabihin, first order reaction natin. Pero pag nag-plot naman tayo ng A versus time, as in concentration lang, tapos nakita natin na ito may pinakamalaki R squared sa iba, ibig sabihin, zero order siya. Kaya, it's important to plot everything. Yon, gawin nyo yung ginawa nyo kanina. Get the equation of each. Tignan nyo yung R squared. Kung ano yung pinakamalaki sa kanila. Then, that's when you can conclude kung, hindi pala ako nagpakita nung ano. Hindi pala ako nagpakita ng slide. Shucks. Ulitin ko na naman ba? Sorry. Ano ba yan? Teka lang, ha? So, I was saying, so pag second order, pinat natin yung 1 over something versus time. Pag siya yung pinakamaling R squared, pinaka-line siya. So, second order action. Pag naman pinat natin, concentration versus time, and siya may pinakamalaking R squared, siya yung order ng reaction. And lastly, kapag first order, pag nagplot tayo ng ln versus time, and siya may pinakamalaking R squared, ayun, siya yung first order reaction siya. So, therefore, repeating lang, plot nyo lahat, gawin nyo yung ginawa nyo kanina, then compare nyo yung R squared nila. Then, yung may pinakamaking R squared, yun yung order ng reaction. Always remember that, ha? So, that's the steps. Ayun. Gets ba, guys? Sorry. Okay naman?
Okay, sir. Yes.
Okay, sige. Now, let's move on. Balik tayo sa tanong kanina. Ano yung rate constant? So, sige, balikan natin yung equation ng kanina. Balikan natin yung equation natin kanina. Diba yung, sige, if you understand the concept, ano yung K? Ano yung rate constant natin? Given na ito yung equation natin. Yun yung integrated rate law equation natin. Second order siya. Kasi, ang nakuha natin dyan, 1 over something versus time. And yun yung nakita natin yung pinamalaking R squared. So, ito yung integrated rate law equation natin. So, sige, based on the concept kanina, ano yung rate constant kaya? Giveaway siya.
Yung slope.
Yes, exactly. Ayun. So, take note, sa mga ganitong problem, ayun na. Diba, meron ka lang ng equation of the line. So, giveaway. Giveaway yung ating slope. Ito siya. So, yan na yung rate constant natin. Yung unit niya, dahil second order siya, ay per ms. Okay? Yun siya. Dimensional analysis lang yan. Next, ang huli natin tanong is, find C4H6 at time equals 8,000 seconds. So, to get that, di ba meron na tayong equation of the line? Yun lang, substitute lang natin doon. Yun na siya. 1.69 times 10 to the negative 3 molar. Okay, nagets ba to? Okay naman?
Yes, naman, sir.
Okay, sige. We'll have more of that. Nag-upload din ako nito. So, let's move on to the next one. Half-life. What's half-life? Time it takes for the reactant concentration to reach half its value. So, pag titignan natin yung time nito, ayan no, yan, 0.6 siya sa start. So, ito pala ay decomposition of N2O5. So, nag-start siya at 0.6. 1/2 siya. Ayun no, 0.3 at 24 minutes. So, therefore, ang half-life ng N2O5 ay 24 minutes. Yun siya. Yun yung concept niya. So, paano kunin yung half-life for each reaction? So, bale, diba, ang first order reaction ay ln A naught over 80. Substitute nyo lang parati yung ito, 1/2 A naught. So, you'll get this. Okay? Yun yung derivation niya. So, for the other reactions, that's what follows din. Okay? Try nyo na lang sa sarili nyo. Let's try this out. Sige. What is the half-life of this reaction? And as a follow-up question, how long does it take for this one to reach 1/4 of its concentration. Go. Sige, let's set 3 minutes lang. Let's go. TLDR, ito lang siya. First order reaction siya. Then, I'll write the formulas sa board in case na you didn't get it. Yes, tama. Tama ka, Mau. Good job. Yan, I wrote the formulas on the board in case na Good job. Okay, good job. Sige, let's discuss. Sige, let's look at the board. Yung una, plug and play lang. Kasi ln2 over k. Kasi sabi ko, first order reaction siya. So we'll get 0.075 seconds. So letter B, there are two ways to approach that. Diba half-life siya? 1/4. So, diba at first one, 1/2 matitira. So yung next one, yung next na half-life, 1/4 na lang matitira. So basically, 0.075 times 2 equals 0.15 seconds. In another solution naman, you can use this. Pwede rin to. Ito mismo. ln ng A naught over 1/4 A naught equals KT. Then solve for T using this. You'll get the same thing dapat. Okay? Sige. Gets naman? Let's go. We're almost done sa natin. So yan, this is a summary. I'm going to upload this naman later. Para So yan, that's everything for the integrated rate law. Sige. Let's move on to the last part of our lesson today before we start answering our exercises. Activation energy. So, Arrhenius equation, ito naman in terms of temperature talaga, dependent on temperature. Rate constant can be expressed as K equals AE. Yung E pala dyan, yung sa calcu nyo, yung parang italicized na E, which is equal to 2.718. Yun pala yung sabihin ng E dyan. um, AE raised to negative activation energy over RT. Ang RT dito, ang R dito ay ano pala, sorry. Teka lang ha. Let me just check my resources. This equation R. 8.314 joules per mole Kelvin. Okay. Teka, dagdag ko lang. Joules per mole. Yan. Hindi siya yung 0.08206. So, ang gas constant natin dito ay 8.314 joules per mole Kelvin and yung temperature of the reaction in Kelvin, syempre. Okay? So, plotting, ito na naman, plotting. So, in short, pwede, you'll see sa exercise nyo. Pwede rin to. Let's see later. Plotting ln k versus 1 over t gives a straight line. ln k equals ln a minus ea over r times 1 over t. So basically, I just got the natural logarithm of the both sides and we have an equation in the form y equals mx plus b. Y equals b plus mx. So therefore, yung slope ng line na to ay negative ea over r. So given two temperatures, ito yung formula natin for that. Mamaya may example tayo for these exercises. Pero last concept na I want to discuss for today, activation energy. Energy threshold that the colliding molecules must exceed in order to react. So, dito, looking back at our equation, smaller EA, or kapag mas mataas yung temperature, mas magko-collide yung mga particles natin. Kasi nga, na-discuss ko na to kanina. Then, ibig sabihin nun, if you look at yung equation natin kanina, mas tataas yung K, and therefore, pag mas mataas yung K, pag, as we saw in our other slides, tataas yung rate natin for the reaction. And last concept, delta H reaction is equal to the activation energy forward minus activation energy reverse. We won't focus on that too much naman. Pero yan, this is what you call an energy diagram. Ito yung sabihin niyan. This is our start. Ito yung end. So, EA forward minus EA reverse. Kasi nagre-release tayo ng heat para makaform ng gas. Transition state, yun pala yung tawag dyan sa taas. So, pag itong O3 plus O natin, na-reach niya to, magiging O2 na siya. Yun ang sabihin ng diagram nito. Okay? So, sige, this is our last problem for today before we move on to our exercises. Sige, pakitry nga. Nakuha ba yung formula kanina? Sulat ko lang sa board in case na hindi nyo nakuha. Okay try nyo to. Sige, let's go. Mga 3 minutes. Yung formula, sinulat ko pala sa whiteboard. Nagamit yun na ba sa Chemistry 1 ever na ang R ay 8.314? Nagawa nyo na ba yun? Or hindi pa?
Sorry, sir. Ano yan?
Nung Chemistry 1 nyo ba, na-try nyo ng ang R nyo ay 8.314 joules per mole Kelvin or hindi pa?
Sir, yung R ba yan? Yung sa gas or ano?
Yeah, gas constant siya. Ang gas constant dito ay 8.314. Di ba meron din yung 0.08206 sa mga gas law? Hindi yan for this time. Okay? Yan, the formula is flashed there. Or in essence, para hindi siya mahirap kabisaduhin, pwede rin siyang ganito. Pwede rin ganito yan. Finactor out ko lang yung negative sign. Same thing. Lang, kasi mas madali na tandaan.
Sir, saan ulit equal yung R?
Sorry. Ang R ay equal sa 8.314 joules per mole Kelvin. Let's see. Mali eh. Miraiza, check your exponents. Baka may mali somewhere. Pag 1.76 times 10 to the 5th. Yes, tama, Megan. Good job. Okay, tama na yan, Meliza. Sige, let's just wait a bit on the others. Ay, na-discuss nyo na ba kung nagsabihin ng LN nung grade 9 kayo or hindi pa?
Sir, na-discuss.
Na-discuss na. Okay, sige. So, in short, nakapag-logarithm na kayo nung grade 9.
Apa.
Okay, sige. Over 1.9.51 times 10 to the Okay. Sige, tama yan. Just wait for one more. Ay, for two more pala. That's good. Sige, last one. Okay, let's discuss. Tama kayong lahat. Good job. Let's just look briefly at the board before we start with our exercises. So, ayan, I wrote it na. So, ito yung equation natin, di ba? Tapos, ayun, solve for EA, simplify your algebraic expression, and substitute all required values, you'll get this. Okay, nakuha naman lahat. Good job. Sige, that's the end of our lesson. Pero, before we go, ay, sorry. Naalis ako sa meeting. Hello, sorry. Okay, I was saying, okay, so we'll do the same setup ulit like last meeting. If you check your drive, if you check yung Google Drive, nandun na lahat yung materials for today. Ganun ulit, may sagutan ulit tayo. And we would discuss it again sa next meeting, some selected problems. So for today, I just want you to answer 3 items that I think are really important. I'll just type it dito sa, answer. Number 1, number 4. Teka ha, number 1, number 4. Answer number 1, number 4, and 1, 4, 5. 1, 4, 5, 9. 1, 4, 5, 9, 10, A. Okay, sige. Ayun, we'll answer until for 20 kasi sorry, I had some things to attend to in the middle. So yan. Nakita niyo na yung sa drive? Did you see it naman yung in-upload ko sa drive? Did you see yung in-upload ko sa drive, guys? Teka, share ko.
Ako sir, yung session 2.
Yeah. Okay. Just paste it here. Sige, I'll just leave your questions lang sa group chat. I'll just have a bathroom break. Okay, sige. Nakakain na to. uy. 70. Huwag na, kaya na. Okay, I'm back. I'm sorry. Sige. And if you have questions, go lang. You can post sa group chat natin. Sarap tong ano pa, yung sarap ng chicken pastel ah.
Ano ka mo?
Sarap ng chicken pastel.
Ah, yung makinain mo. Makinain ko yung giniling, saka yung...
Hmm. Lakas palang kumonsumo nitong Droid Cam na to. Alam mo ba nakailang gig na ako? For the past 2 weeks? 100 gig.
Yung inaano mo?
Oo.
Ilan gig ba yan?
Hindi. I mean, ganun karaming data yung ginagamit niya. Grabe, no?
Hindi ko alam yung sinasabi mo.
Yung data usage.
Ah,
Ang dami lang talaga. We have, sige, mga 5 minutes more. Oh, sige na. Go, send me na lang whatever you have sa whatever you have answered ngayon, it's okay. Send na lang sa akin through PM. So, sige, send mo na before we end. Go, go, go. Teka na nga. Dali, I'm waiting for 2 more people na lang. Let's go. Oh, guys, send na. Tara. O yun, I posted na yung final reminder ko sa inyo. Sige, let's call it a day. Maraming salamat sa pagpunta. Ayun, read na lang yung reminder ko sa group chat. Then, ang next natin sa physics ay waves and acoustics. Or, actually, your choice. Ano ba mas gusto nyong unahin? Teka. Ano ba mas gusto nyo unahin sa physics? Electricity or waves and acoustics? Ayun. Oh, sige na. Ano ba mas gusto nyo unahin sa physics? Waves or electricity?
Ano ba sir yung mas logical na order?
Well, kasi magkaiba naman yan talaga eh. I mean, it's, pero, sige, I think we'll need more time sige, let's just go with electricity. Tingin ko, kasi mas kailangan nyo
Sige.
yun eh. Okay, sige. Ayun, maraming salamat. Yun na, sige, let's call it a day. Bye.
Sige sir, thank you.
Bye.